Hello friends, today we'll see the joint method of trusses. So it is also one of the most simple way of getting the forces in the members of truss. And specially joint method of trusses means it's a application of concurrent forces, and section method means non-concurrent forces. So which are the basic steps for solving this problem? So always free body diagram you have to draw. First step is free body diagram. And in the second step, what you have to do, find at least one reaction by using free body diagram of simply supported truss. Means if supports are at two sides, then in that case find out at least one reaction. And no need to find out the reaction in case of cantilever type of truss. Cantilever type of truss, no need to find out support reaction. Directly you can start the solution of the problem. And the most important thing in this is what? We have to draw the free body diagram of joint where only two unknowns are there. Because we are going to use only two conditions, summation fx is equal to 0 and summation fy is equal to 0. This is very simple procedure of finding the forces in the members of a truss. So I'll explain this with directly with one example. So very first example of truss which we'll take is determine the forces in all members of truss. So first we'll see how many members are there. 1, 2, 3, 4, 5. 5 members are there, means we have to get 5 answers from this. Very first step, draw the free body diagram. And free body diagram means what? Replace this supports. So this is one support, we have to replace it by one reaction, and this is other support, we have to replace by two reactions. How I'll replace this? That it was the roller support, this single reaction RD, and it is the hinge support. Here there will be two reactions AX and AY. So it is what? The free body diagram. So this is the free body diagram. So first step is free body diagram, and again one more additional thing we have to do. So whenever any inclined force is there, then in that case it is always better to get the angle of that inclined member. Then here this AC is inclined member and BC is inclined member. Then how we can get this inclination of this? If suppose this is theta and this is suppose beta, then what will be there? Theta is going to be tan inverse of 1 by 2 and beta is going to be tan inverse of 1 by 1. Actually this distance is 1, this is 1, so it is going to be 45, or directly you can write that this angle is 45. So this is 45 and theta is going to be tan inverse of 0.5. So tan inverse of 0.5, it is going to be 26.56. So if any inclined member is there, get its angle first. So that is the step. Then after that, what I have told, if suppose the cantilever type of truss is there, means supports are at one side only and other end is free. For example, B is free end, only two unknowns are there. In this case, no need to find out the support reactions also. Then what to do in this case? So here directly you can draw the free body diagram, and for free body diagram of the joint, so we can start with joint B. Now see carefully how we can solve this. It is joint B and its free body diagram will be. So for drawing the free body diagram also, I'll always suggest first you draw such cross plus sign, means here there will be a joint, and now you can mark the members. So at B, so this AB member is horizontal. This AB member is horizontal. Weight is, or the force, external force is downward. Yes. it is downward 5 kilonewton, and this BC member is making 45-degree angle. It is 45 degree. So this is the joint B. So this member is FAB and this is FBC. Then one very important thing I'll tell, how to choose the correct direction in the trusses. So truss is the application of equilibrium. Now this known force is downward. Means to balance this member should be upward. And when it is upward, this direction is towards joint. Towards joint means compressive. Now again this force is towards right. To balance this cannot be towards left. So this must be towards left. Means it is away from the joint. So it is a tensile member. And now you will 100% you will get positive answer, and positive answer means your assumption is right. So for solving this, again, even though three forces are acting at a point, they are not in one direction, either away or towards. So do not use Lami's theorem. Simply you use the basic conditions of equilibrium. There also, which condition we should use first? When unknown is horizontal, use summation Fy first. When unknown is vertical, use summation Fx first. Here unknown is horizontal. Then the first condition will be what? Summation Fy is equal to 0. For summation Fy, FBC, this FAB will not be in picture. FBC sine 45, it is upward, plus minus 5, it is equal to 0. Then what will be FBC? FBC is going to be 5 divided by sine 45. So that answer will be 5 divided by sine 45. It is 7.07. It is 7.07. Direction is correct. So that's why the magnitude is 7.07 kilonewton. And direction FBC towards the joint, it is compressive. It is compressive, means one answer we got. Then second answer, how we can get? Use another condition of equilibrium, summation Fx is equal to 0. We'll get FBC sine 45, means 7.07 cos 45, not sine, it is cos 45. Horizontal component of this, it is towards right, positive, minus FAB, it is equal to 0. That means FAB is equal to, again, 5 kilonewton. This is also positive, means it is away from it. It is tensile. Means with one joint always we get two answers. Forces in two members we got. Actually 5 members are there. And here what you do, so whatever the member you are getting the answer, you show the direction. FBC. FBC is what? It is compressive. Compressive means towards the joint. And AB tensile. Tensile means away from the joint. So these are the two members. Means here we'll understand that these two members are known. Now the next joint we have to consider. So how we can consider the next joint? Where two unknowns are there only, and at C only these two unknowns are there, so that we can easily analyze. So what will be the next step? So here we must write joint C, and I have told the first step is going to be its free body diagram. And while drawing the free body diagram, what care we have to take? Draw the plus sign first, and then afterwards Now try to draw that joint's free body diagram. So at C, this BC member is inclined at 45 degree. And how is it? It is compressive. It is like this. Its value also we are knowing, 7.07 kilonewton. Then one member is horizontal like this, and third member is making 26.56 angle. Inclined member's angle we must know, it is 45, it is 26.56, and one direction is known. So this member is FAC, and this member is FCD, FCD. Now it is towards left or it is downward, so this cannot be upward. So this member cannot be upward, hence this member should be upward. And if it is upward, automatically it becomes tensile. Now both these members are towards left, means this must be towards right. When three members are meeting at a point, the direction of one force or one member is known. Easily we can choose the perfect direction, and you have to get the correct direction like this only. Then again, what is the way? Now it is a concurrent force system. Two unknowns are there. We can use two equilibrium conditions. And how we should use? That unknown is horizontal. Then very first condition which we'll be using is what? Summation F y, it is equal to 0. Then here FAC sine 25.56 minus 7.07 sine 45, it is equal to 0. It is equal to 0. It is upward plus, it is downward minus, and from this we will get the answer of one member, FAC, and that answer will be what? 7.70 into sine 45, it is equal to 5, divided by sine 26.56. It is 11.18. 11.18 kilonewton, and it is 11.18 AC away from the joint tensile member. Then summation Fx is equal to 0. Another condition of equilibrium. Summation Fx is equal to 0. FCD, which we have to calculate. FCD minus AC means 11.18 cos 26.56 minus 7.07 cos 45. It is equal to 0. And from this, we will get FCD. This is going to be 11.18 into cos 26.56 plus 5. It is going to be 15. FCD, it is 15 kilonewton. And FCD, 15 kilonewton, it is compression. Means with two joint, we got 4 answers. Only one answer is remaining. And that answer is this AD member. And even though that answer we can get easily by simply observation. Means in the trusses, if three members are meeting at a point, and out of those 3, if 2 are collinear, then force in the third member is always 0. Means this is going to be 100% 0 force member. Means just simply by observation, we can tell FAD is equal to 0. Means all the answers we got easily, and at the end I'll always suggest prepare the table like this. So many times in the question itself there may be a instruction that find the forces in all the members and tabulate the result. So here what we have to prepare, this is the member, first column, then force in the member and its nature, whether compressive or tensile. Now here how many members are there? There are going to be 5 members, 1, 2, 3, 4 and 5 members. So you can prepare such table, and this answer simply you have to write AB, member is AB, member AB, and we know the answer of AB is 5 kilonewton. It is tensile. Then AB BC or AB AD. AD is 0. Nature, it's neutral. No need to write anything. Then BC. BC is going to be 7.07 kilonewton compressive. Then AC member is 11.18 kilonewton. It is tensile. And the last 5th member is CD. That CD member is 15 kilonewton compressive. So like this, in general, we have to solve the problem of truss. And at the end, if you tabulate the result, it will be much better. Problems are not difficult. Step by step, silently, we have to solve it. Now we'll see the second example of truss. Determine the axial forces in each member of the truss. So this is also simple truss. Only 5 members are there, and we have to find out these 5 answers. So as I told, the very first step in the trusses is what? So we have to replace these supports. Actually it is the roller support, means single reaction at D and 2 reaction components at A. So here there will be 2 reaction components, and here a single reaction. So at A, as there is a hinge support AX, AY, AX, and a single reaction, it is RD. So again, always in the truss, so I'll always tell, so only 3 members including external force also, if they are meeting at a point, and out of those 3 members, if one is, or if 2 are collinear, then the force in the third member is always 0. Means in this example also, just simply by observation, I can tell the force in the member AD is 0. Means this is the 0 force member without doing anything. So while solving this problem, you can write by observation of the free body diagram. By observation, F AD is equal to 0. Means any student without doing anything can get 1 or 2 marks by this. F AD, it is going to be 0. Then after that, what is our normal method? If such type of truss is there, simply supported type truss, then at least 1 reaction we have to get, and we can get RD. How we can get? So for whole truss, means for this truss, use summation m about A, it is equal to 0. And from this what we'll get? The moment of AX, AY and 15 is 0. So the moment of 10 kilonewton clockwise, 10 into 3 minus RD into again 3 anti-clockwise, it is equal to 0. Hence, we'll get RD is equal to 10 kilonewton. RD is equal to 10 kilonewton. So we got one reaction. And even though here you can write RD is equal to 10 kilonewton. Now, we can analyze and again see by observation FAD is equal to 0. And force in the member CD is equal to RD. CD is equal to RD. If RD is upward, means CD is going to be downward. And this is going to be compressive member. So here you can write by observation FAD is equal to 0 and FCD is equal to RD. And if we calculate RD by using the moment ITA for the whole truss, hence two answers we got. FAD is equal to 0 and FCD is equal to RD, that is 10 kilonewton. 10 kilonewton. 10 kilonewton, how it is? Towards the joint, towards D, means compression. See, after free body diagram, simply by observation and by knowing one reaction, we got two answers, AD as well as CD. Now at C, this BC and AC is unknown, means which joint we have to analyze? So we have to analyze the joint C. Joint C. Again, the procedure is same. So I'll suggest draw the plus sign, light lines, and then afterwards at C, 3 members are there. Out of those 3 members, one is horizontal, other is vertical like this, and third one is. So when 3 by 3 means straight away this inclined member is making 45-degree angle. Now here known value is what? CD member compressive. Compressive means towards the joint. And this CD member we are knowing 10 kilonewton. If it is 10 kilonewton upward, then this cannot be downward. This must be downward. It is towards left, then it should be towards right. Means easily we can get the correct directions. So this is 10 kilonewton, this horizontal member is FBC and this inclined member is FAC. Again the procedure is same. Two unknowns, use equilibrium conditions of concurrent forces, summation Fy first, because one unknown is horizontal. 10 is upward minus FAC sine 45. It is equal to 0. Hence, FAC is equal to 14.14 kilonewton. AC away from the joint. It is tensile. And if we use summation Fx, it is equal to 0. That FBC, it is towards right, minus 14.14 cos 45. This 10 will not be in picture. And from this, we'll get FBC is equal to 14.14 cos 45, it is 10 only. 10 kilonewton. And this member, BC, it is compressive. Means out of 5 answers, easily we got 4 answers. So this BC, AC is tensile. AC is tensile means like this. and BC is compressive. It is like this. It is like this. And now which answer is remaining? Only BC. And by observation at joint B, no need to draw its free body diagram also. So this BC is 10, this is also 10. So if it is 15, means by observation itself, it should be upward, means towards the joint compressive, and simply you can write at joint B by observation only. By observation, F AB is equal to 15 kilonewton towards joint means compression. Means like this, easily we can get the 5 answers. Again, we can write or we can prepare the table like this: member, force, and nature. Member is what? AB. For example, AB member. And in AB member, what is the force? 15 kilonewton. And how is it? Nature, compressive. Then second is what? AC. AC also we have calculated. 14.14. 14.14 kilonewton. And AC is tensile. Then AD, it is a zero force member, it is zero, nature is neutral. Then 1, 2, 3, BC. BC is, its magnitude is 10 kilonewton. 10 kilonewton towards joint compressive. Towards joint compressive. And then last one is CD. CD, so it is also 10 kilonewton compressive. Means 3 members are compressive, 1 tensile, and 1 is neutral. Means either simply you can write like this, or if you wish, you can enclose it in the table also like this. It's up to you. Finish. This is the complete answer of this truss example. Now we'll see the third example on truss. Determine the force in each member of the truss and state if the members are in tension or in compression. So if you see the truss, so again it is supported at two ends, at A and D. Means first step is what? Remove the supports. At A, 2 reactions, and at D, a single reaction. So how we can show it? So these reaction components are like this. It is AX, it is AY, and at D, RD. So now reaction at D. So this is the free body diagram of that truss, a very first step. Then what we have to do? At least we have to get one reaction. Means if we take the moment at A, we will get the reaction at D. Now that reaction we can get by various ways. Even though by symmetry also we can get. Because here AX is going to be 0. There is no other additional or extra force acting on it in horizontal direction. Only AX. It is 0. And it is simply symmetric truss. Means whatever the reaction at A and at D, it must be same in upward direction. So either sometimes by observation only you can tell AY and RD is equal to 5, or the best way is what? Summation M about A, it is equal to 0. And what is it? 10 into 2 minus RD into 4, it is equal to 0. Hence RD is equal to 5 kilonewton, and it is upward only, means it's right, it is upward. So this is the first step. Then after this, no need to find out AX, AY, it is not asked. Support reactions are not asked, forces in all the members. Then which joint we should consider where two unknowns are there? At D, there are two unknowns, means we must analyze joint D. So this is joint D. This is the joint D. Here there must be D. And how we should draw the sketch, you observe carefully how I am drawing. This is RD. We have calculated, it is upward, known value 10 kilonewton. Sorry, it is 5 kilonewton. 5 kilonewton. D member is horizontal and this member. So now here easily whatever the inclined members are there, equilateral triangles, means all the inclined members are making 60-degree angles. So here with horizontal, so that CD member will make 60-degree angle with horizontal. So here we have to write that this is 60. It is 60. Then joint is D. One known force is there upward. So this cannot be downward. So this should be downward. That means it is compressive. It is towards right. This cannot be towards left. This is towards left. So this is the proper way of choosing the perfect directions. So it is FDE and this is FCD. FCD. Now unknown is horizontal. Straightway you use condition summation Fy is equal to 0. For summation Fy, 5 minus FCD. FCD sin 60. It is equal to 0. Then from this we can write FCD. FCD is 5 divided by 5 divided by sin 60. It is 5.77 kilonewton. FCD 5.77 kilonewton. One answer we got. And this answer CD, it is compressive. It is compressive. Then for the second answer, what we'll do? Summation Fx, it is equal to 0. FDE, it is minus towards left, plus FCD 5.77 cos 60. It is equal to 0. Means 5.77 into cos 60. And it is going to be 2.88. It is 2.886 or 2.88 or 89. FDE 2.886, you can write or you can write 2.89. Both are correct answers. So it is going to be tensile. Means two answers we got. FD, it is tensile away from the joint, and FCD, it is compressive. Means in this truss we got two answers. Then now the next step is what? The next step, another joint we have to consider. Then which joint we should consider? It is A, B, C, D, E. So A, B, C, at C, two unknowns are there. This is unknown and this is unknown. Then here also, it is very important how we are drawing the free body diagram. So joint C. Then how will be drawing the joint C? Again plus sign. For the plus sign at C, this is C, it is horizontal. Then 60 degree with horizontal, that means it is like this, it is 60. And again this is also 60 with horizontal, like this. It is 60, it is 60, it's C. Now ABC, this is FBC, and this inclined member is FC, and this is the known member, so we have calculated FCD. FCD is 5.77 kilonewton. Now how we can choose the direction? It is upward, so downward must be this, means tensile, away from the joint. This is towards left, this is also towards left, so it should be towards right. So these are the perfect directions. Now unknown is horizontal. First condition will be summation Fy, it is equal to 0. It is Fy, it is equal to 0, and Fy is what? 5.77. 5.77 sin 60 minus FC sin 60, it is equal to 0. This sin 60 will get cancelled, and FC, it is 5.77 kilonewton only. So it was compression, now this is tensile. FC, it is 5.77 tensile, and if I use summation Fx is equal to 0, what I'll get? FBC minus 5.77 cos 60 minus 5.77 cos 60, it is equal to 0. Means FBC 5.77 cos 60, it is 2.88, again 2.88, FBC is 5.77 only. And how is it? 5.77 BC towards the joint, it is compression. Means out of how many members? Out of 1, 2, 3, 4, 5, 6, 7 members, we got the answers of 4 members. 1, 2, 3, 4. And if you see it, FBC, it is compressive. So it is FBC, it is compressive, means it is like this. It is FBC. And FC, it is tensile. Tensile means away from the joint. So these answers we have got. Now by using the symmetry, by using symmetry, what will be there? And just this is like table only. F, A, B. So this is B, this is C. F, A, B. This must be the member like F, C, D. and we know this answer. FAB is equal to FCD, 5.77 kilonewton. It is compressive. Means these are the two answers. Then FAE, it must be equal to this AE and DE member must be same. FDE is equal to 2.886 kilonewton, and both these members must be tensile. And then FB is equal to FC. FB is equal to FC, and FB is equal to FC 5.77 kilonewton. It is tensile. So like this we got 6 answers, and finally you can write and 7th answer, that FBC. That also we have calculated 5.77 compressive. 5.77 kilonewton compressive. And here I think there is no need to prepare the tables also. At the one place we got 7 answers. So 3 5.77 compressive, 2 tensile 5.77, and 2 are 2.886 tensile. So this is the solution of the truss example. Even though it looks lengthy, I don't think that logically if you solve easily you will get the answer. Thank you.